And then from there, we're just going to solve for b and figure out what it is. So we have to get b by itself. So we're going to use the addition property of equality. We're going to get rid of that -9, right? Addition property of equality. That cancels. We're left with 27b equals 180 plus 9, which is 189. Then we're going to get b by itself, right? That's 27 times b, so we have to do the inverse operation of multiplication, which is division. So division property of equality, divide both sides by 27. And 189 divided by 27 is actually equal to 7. So we know that b is equal to 7, right? Simplifying. But what is the problem asking us to find? The problem is asking us to find the measure of angle z. So we found what b is, right? That's great, but we have to find out what the measure of angle z is. We can do that. We know that the measure of angle z is equal to 9b plus 2, right? That is given information. Then from there, we're just going to substitute in. So substitution. Then we have 9 times 7 is 63 plus 2 is 65. So the measure of angle z is equal to 65 degrees, and all this is just simplify. All right, now it is your turn, ladies and gentlemen. I want you to use this figure right here and figure out you're going to use the same figure for 2a and 2b. So where's my friend? Where's my friend? Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out 2a and 2b. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, let's see how you did on 2a. So what do we know? We know that 2a, we are dealing with a parallelogram, and we have to find JG. Right? Parallelogram means that unlocks the door to these lovely 4 theorems. Okay, so which one are we going to use? What do we have? We want to find JG. That's a part of a diagonal, right? So most likely we are going to be using, if a quadrilateral is a parallelogram, so if you have a parallelogram, then the diagonals bisect each other. We're going to be using this one. So, yeah. Okay, let's go ahead and get started. So the first thing you have to say is that you're dealing with a parallelogram, right? And then the other given information is EJ is equal to 3W and JG is equal to W plus 8. Then what do we know? We know that if it's a parallelogram, the diagonals bisect each other, which means this is equal to this. These are congruent. So I'm going to say that JG is congruent to EJ, right? If it's a parallelogram, the diagonals bisect each other. We're going to change the format, definition of congruent segments, and then we're going to substitute in. So we know that JG is equal to W plus 8 and EJ is equal to 3W. That's just substitution. Then we want to use our algebra, right? We're going to get the variables on the same side. I'm going to move the smaller. So we're using that subtraction property of equality. That cancels out. We're left with 8 equals 3W minus W is 2W. That's simplifying, right? Now we're trying to get W by itself. This is 2 times W, so we have to do the inverse operation, which would be division. Division property of equality to both sides. We end up with 8 divided by 2, which is 4. And 2 divided by 2 is 1. 1 times W is W. So we have 4 equals W, which is simplifying, but we always want to write that variable on the left side. So we're going to use that lovely, magnificent, symmetric property of equality so that we have W equals 4. Now, are we done? No, we're not done because we have to find JG, right? That's what the problem's asking. So we got to go over here. We know that JG is equal to W plus 8, so that's given. We're just going to substitute in that W is equal to 4. And 4 plus 8 is 12. So boom, shakalaka, there you have it. JG is equal to 12. So if you got that right, awesome, awesome. Let's go ahead and see how you did on 2B. 2B or not 2B? Okay, so we're going to 2B it. It says find FH. So we're finding the whole thing, FH here. Very interesting. So we have this and we have this. Ooh, this is so exciting. So many different ways. Okay, so let's go ahead and, so FH, right, that's a diagonal. We know it's a parallelogram, right? We know that this is a parallelogram. And this is a diagonal, so we're going to be using that. If it's a parallelogram, then the diagonals bisect each other, okay? So, let's go ahead and write down our given information. So we're going to say that parallelogram EFGH, right? And then let's go ahead and write this information here because we really need to figure out what Z is, right? So let's go ahead and say that F, well, we could just do this one. This would be fun. J, well, we need to figure out what Z is. And we know that these are congruent, so we need both of these. Okay, so FJ is equal to 4Z minus 9, and JH is equal to 2Z. And that's given. Perfect. Okay, so now we just want to say that these are congruent to each other. I know we want to find FH, but we need to figure out what Z is first. Okay, so we have to set these up and say that they're congruent. So we're going to say that FJ is congruent, line segment FJ is congruent to line segment JH. Okay, that is, if it's a parallelogram, then the diagonals bisect each other, which means those two segments are congruent. Okay, then we need to change this, right? So FJ is equal to JH, definition of congruent segments. Then we substitute in, so 4Z minus 9 equals JH is 2Z. Okay, substitution. Okay. We want to get the Z's, we want to figure out what Z is. So usually I move the smaller, but this one's already on this side by itself, so I'm going to move this one over. I'm going to subtract that. That cancels. We're left with negative 9 equals 2Z minus 4Z is negative 2Z. Okay, so what was that? Subtraction, property of equality, and then simplify. Okay, we want to get Z by itself. So we're going to divide both sides by negative 2. That leaves us with a negative divided by a negative, which is positive, and 9 over 2, we'll just leave it as 9 over 2. 9 over 2 equals negative divided by negative is a positive, 2 divided by 2 is 1, 1 times Z is Z. So there we have it. Z is equal to 9 over 2. Oh, this is division, property of equality, and then simplify. Okay, so I'm going to have the Z on the other side. So that's symmetric property of equality, symmetric property of equality. Okay, perfect. Now, what's the question asking us to find? The question's asking us to find FH, right? So I need to find FH. So what do I know about FH? Oh, wait, could you see that? I'm sorry. So I'm going to leave it as a fraction. I think when I'm looking at this, right, FH, there's this one and this one. I think I'm going to use the easier one, this one. I'm going to say FH is equal to 2 JH's, right? Because 2 of these equals the whole. So that's what I'm going to use. So I'm going to take this and go right over here. And I am going to say that FH is equal to 2JH. And that's because if it's a parallelogram, then the diagonals bisect each other, right? I'm going to substitute in what JH is, right? JH. Oh, could you even see that? My bad. So I wrote this, FH equals 2JH, because if it's a parallelogram, the diagonals bisect each other. Then I'm going to substitute JH in, so JH is 2Z. So 2 times 2Z, okay? That's just substitution. And then I can simplify that, right? 2 times 2 is just, well, I'm just going to leave it like this. And I'm going to substitute again because z is equal to 9 over 2, right? So I'm going to substitute that in. So I have FH equals 2 times 2. Instead of z, I'm going to write 9 over 2. And that is just a substitution again. And then we're just going to simplify. And the lovely thing about this, keeping it in fractional form, is that those 2's just cancel out, right? Because 2 over 1, right? They cross cancel. You look to cancel out and then multiply across. And then from there, it's just 2 times 9 is 18. So FH is equal to 18 by simplifying. So if you got that right, you did a wonderful job, and I'll see you in a little bit for example 3.